In this video, we will discuss the problem night walk. The problem says that we have been given a square shaped chessboard and the initial position of the knight, and we have also been given a target position. So our task is to find the minimum number of steps in which knight can reach the target position, and if the knight cannot reach the target position, that we have to return a -1. So whenever we get this thing that we have been given a board, here particularly we have been given a chessboard, and we need to reach from a particular source destination to a particular destination. In that case, if we want to find the minimum number of moves to reach from the source to the destination, so which algorithm comes to our mind? The algorithm that comes to our mind is nothing but the breadth first search, because the breadth first search algorithm helps us to find the shortest path. It helps us to find the shortest path between the source and the destination, right? Between the source position and the destination, it helps us to find. So BFS comes to our mind, because if it is asking for the minimum number of moves to reach from the source to destination, then on a board, then the BFS comes to our mind, correct? And if we cannot reach it, then we'll return a -1 simply. And notice that the the board will be 1 based index. Okay, so the indexing of the board will be 1 based, it will not be 0 based. So if suppose that n is equal to 6 is given, so the initial position of the knight is 4, 5. You can see the knight is standing here on this board, and the target position is 1, 1. Okay, so in that case, what will happen? If you have to reach this cell, because you can see 0, 0 will not be there because this is 1 based. So what you will be doing here is, you can see that the knight can take actually 3 moves, like 1 move here, then this is the like from 4, 5, it can go to 5, 3 in 1 move, then it can go to 3, 2 in the second move, and after that it can go to 1, 1 in the third move. So basically it will take 3 moves, and that we can get using the BFS part. So first thing is that how does the knight move? So if we will think like how does the knight actually move, what are the movements of knight on a chessboard? So basically we say that it moves something kind of 2.5 turns, but let's like 2.5 walks. But in terms of movements, I can say that, suppose let's take a grid, like let's first of all quickly take a grid of 5 cross 5 size quickly. So let's say we have a grid of 5 cross 5 size. So let's draw it. So let's draw it like this, like 1, then 2, suppose this is 3, and this is the fourth part. Okay, let's draw 5 columns here as well, 1, then 2. Okay, so I'll draw it more properly. So let's quickly take some time and draw it. 1, then 2, then suppose this was 3, this was 4. Okay, now suppose that the knight is currently standing here. Okay, suppose that this is the position X where the knight is standing. So how can the knight make the movements? Basically, either the knight from here can go two movements up, and then he can take one direction towards the right, or what he can do is he can stand here, he can take 2 movements up, and then he can go to the left. Okay, this is what he can do. Other thing that the knight could have done is that the knight could have moved from here, he could have moved 2 towards the left, 2 direction towards the left, 2 movements towards the left, and then 1 movement upwards. From here also it could have done what? It could have moved 2 movements towards the left and then 1 movement upwards. From here it could have moved 2 movement rightwards and then 1 movement downward. From here what it could have done is it could have moved 2 movements towards the left and then 1 movement downwards. Okay, so you can see that how it is moving. Then from here what it could have done is it could have moved 2 movements downwards and then 1 movement towards the left, or it could have done what? It could have moved 2 movements downward and it could have moved 1 movement to the right. So basically it, like from a particular cell, the knight can have 6, say like total 8 different positions it can go, right? In one move, the knight can go to 8 different positions, right? But we also need to check for the validity, whether the position that the knight wants to go, whether it is valid or not. So we'll also keep a track of that. So this is how it can move. But how do we get the actual idea about it, right? So suppose this is the grid. So suppose this is the 0, right? This is 1, suppose this is value 2, suppose this is 3, suppose this is 4. Okay, suppose this is 0, 1, 2, 3 and 4. Okay, okay, let's do one thing. Let's write it in terms of 1 based index only, since they have given us in 1 based index. So let's quickly write it like this: 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So what is the original position of the knight? The original position of the knight is nothing but 3, 3. Okay, now if you see, so what is the first position? I'm first of all checking this particular position. Let's say if I'm checking for this particular position, So this particular position is what? It is nothing but 2 comma 1. So 2 comma 1. So what is the change that I had to do? So I can say that the x coordinate was reduced by 1, and the y coordinate, like if I can see, y coordinate was reduced by 2. Okay, this is the change. So I'm writing the change here, right? Writing the change, and this is the positions, right? Positions to which it can move. Okay, after this, if I see further, so let's say if I check for this particular position, so this position is what? 1 comma 2. Okay, so this is nothing but 1 comma 2. For this, how much change I had to make? I had to make the change, like how much change should I, like how much change to the x did I make? I made a minus 2 change. And how much change did I make to the y? So to the y I made a change of minus 1, correct? After this, if I consider this position, so this position is nothing but what? It is nothing but 1 comma 4. So how much change did I make? So I'll make a change of nothing but minus 2 to the x coordinate and plus 1 to the y coordinate. If I see another place, so if I see for this particular position, so what is this position? This position I think is nothing but 2 comma 5. So how much change I'm making? So the change that I'm making to the x and y, this is nothing but I can use them as the dx and the dy to get the new x and the new y positions. Okay, so how much change am I making? Minus 1, and this will be nothing but plus 2. Okay, y will be nothing but plus 2. After that, if I see another position, so if let's say if I check for this position, so this position is nothing but 4 comma 5. So what change I'm making? I'm making a change of nothing but what? The change is nothing but plus 1, right? Plus 1 and uh, plus 2, right? For plus 1 for x and plus 2 for y. After that, if I see for another position, let's say I check for this position, so this position is nothing but 5 comma 4. So what is the change that we are getting? The change that we will get is 2 comma nothing but 2 comma 1. 2 will be the change, plus 2 will be the change in the x coordinate from the original position, that is this x position, and plus 1 will be the change in the y coordinate. Okay, now let's check for this coordinate. So this coordinate will be what? If I see it, so it seems to be nothing but I think it is nothing but 5 comma 2. Okay, so if it is 5 comma 2, so what will I do here? If it is nothing but 5 comma 2, so I will write here as the change will be nothing but 2 comma 1 here, right? Okay, so have I made some mistakes? Yes, I think I have made some mistakes here, like earlier I was writing it like 2 comma 1. Okay, so if I see it here, so it should be 2 comma 1 there only. There it should be 2 comma 1, but if I see here, so it should be 2 comma 2 comma minus 1. Okay, now if I check for this particular position, so what is the change? The change is nothing but if I write it, so this is nothing but what? It is nothing but if this position is nothing but 4 comma 1, and the change that is there is, the change here is if I'll see the change, so the change that I am doing to the x and the y coordinate, that is the dx and the dy, it is nothing but 1 comma minus 2. Okay, so these are the changes. So basically I can do what? I can, in a dx array, I can store all these positions like minus 1, minus 2, like this, all these x coordinates I can store, right? And in the y I can store the y coordinates, and then that will help me to get through all the positions one by one by running a normal loop, and I'll not have to call for 8 different functions, right? So let's quickly write the BFS code implementation for this particular problem now. So what I'll be doing here is, first of all, I'll be also using a visited array, because if I've already visited a particular cell, then I'll not want to visit it again. So first of all, let's develop the dx and the dy here. So let's say let's first of all write the code, in fact. So what I'll be doing here is, first of all, I will say that if it happens, suppose that the night position, okay, so suppose that the position of the night, okay, is equal to the target position, right? If it is like, if the target position, if the source and the destination are the same, basically, in that case the number of movements required will be nothing but 0. Okay, if that is not the case, so what I will do is, I'll say that, okay, in that case I need a queue. Okay, I need a queue, because in a queue what I'll be storing, I need a queue of pair of int comma int, right? Basically I need a queue of pairs in which I'll be storing a triplet in the queue, in which first of all I'll be storing this part, that is in the pair of int comma int, I'll be storing the x and the y coordinate, and then in the another part I'll be storing nothing but the part which will tell me about the number of moves that I have taken currently. Okay, so what I will be doing here is, I'll also be taking a visited array. So let's take a visited array for n plus 1, and n plus 1 and n plus 1, the 2D array. Then I'll initially mark everybody as 0 in that 2D array. Okay, after I have done this thing, so what I'll be doing further is, in the queue, first of all, if I'll be pushing what, I'll simply push the knight position currently. So I'll push the knight position, the x coordinate of the knight. Okay, first of all I'll push that, then I'll push the knight pause for 1. Okay, after this is done, so what I'll be pushing is, I'll be pushing initially 0 also. That means the number of movements up till now is nothing but 0. Okay, after this part is done, so what I will do is, I'll say that okay, the visited of the, like, I'll say that okay, for the visited, like for the knight, for the current position from which I'm starting, so for that I'll mark the knight as visited. Okay, because the knight has already visited this particular place, because we are starting from here, so we'll mark it as 1, indicating that okay, this particular position has been visited. Then what we'll do is, we'll try to run a BFS, and we'll say that okay, while the queue size is greater than 0, till that point of time we'll keep on iterating, and we'll say that okay, while iterating, what we'll do is, we'll take out the front element. So we can say that, let's say the triplet that we are getting, let's say we name it as T. So the triplet that we'll be getting will be nothing but, it will consist of the x coordinate, y coordinate, and the movement, so and the number of moves that I've taken. So I'll take it out from the front, and then what I will do here is, I'll simply pop it out of the queue. Okay, after this part is done, so what I'll be doing here is, I'll be first of all finding, like in terms of I will say that okay, now what I will do is, I'll find the x-axis. So x-axis will be nothing but the t dot x-axis will be nothing but, like let's say, in fact, without doing this also I can get there. So I'll say that okay, what I can get is, I can say that x is equal to nothing but the q dot front dot first dot. Okay, from the first part dot the first. Okay, that will give me nothing but the x coordinate. And how will I get the y coordinate? Y coordinate will be nothing but the q dot front, from the front of the q, the on the first part of the pair, and the second, right, from the first part and the second, because you can see that this part represents the first part of the pair, and this represents the second. So second represents directly the moves, and the first of first represents the x coordinate, and the first of second represents the y coordinate. Okay, so after I have got the x and the y coordinate, so I'll say that okay, the number of moves that I have taken up till now for reaching this particular node, which is the minimum up till now, I'll get it. So the number of moves will be what, the number of moves will be nothing but q dot front dot second. Okay, it will be stored in the second part, right? After this, what I'll be doing here is, after I get the number of moves as well, so what I'll be doing here is, I'll simply say that now, after this, what I'll be doing here is, I'll be moving in all the 8 directions, correct? So but before moving, what I will do is, after popping it out, I'll check that if the x is equal to the target, like if the x is equal to the x coordinate of the target position. Okay, if the x is equal to the x coordinate of the target position. Okay, and if the, like if the x coordinate is equal to the coordinate, x coordinate that I wanted to reach, and the y coordinate is equal to the target position of the y, right? In that case, if I've reached the destination, so in that case I'll simply return the number of moves that I have taken up till now. Otherwise, what I'll do is, I'll simply run a loop. So for k starts from 0, k is lesser than like 8, then I will do a k plus plus. That for this I'm doing for running through the for running through all the 8 conditions. So the new x coordinate will be nothing but the current x coordinate plus dx, like dx of k, that I'll be generating as I showed you here in this diagram. So this will, like this dx array, I'll be generating dx from here, and I'll be generating dy from all these values, right? So the change in the x and the y that I have to do correspondingly for getting the new x and the new y's one by one. So this will be y plus nothing but dy of k. Okay, after I get this thing, so once I get this, so what I'll check is, I'll check that if it is valid or not, right? So I'll check that if the new x is greater than, like if it is new x is greater equal to 1, and the new y is lesser, like, and the new x is lesser equal to n. Okay, if the new x is greater this, if it is lying inside the cell, and the, like, because it is one base indexing, that is why I'm checking it for greater equal to 1 and lesser equal to n, and the new y is, let's say, is greater equal to n, and new y is lesser than the capital N. Okay, if lesser than equal to the capital N, if the y coordinate is also lying in the range, and the visited, right, and the visited of the new x and the new y, right, if the and this particular cell is not visited. Okay, if it is not visited, so if it is lying in the range and it is not visited, in that case, what I will be doing is, if it is lying in the range and it is not visited, so I'll simply first of all mark it as visited. Okay, So I'll simply first of all mark the current cell as visited. Okay, after like that I'm reaching, I'll mark it as visited, and after that I'll since I'll also store it in the queue, so I'll push it into the queue. And what will I push into the queue? So first of all I'll push the new x, okay, the new y coordinate, and I'll push nothing but how many moves did I take to reach it. So if the parent, if the current position, if for reaching the current position I needed moves, right, I needed a certain number of moves. So for reading this for reaching this particular position, the I'll take one more move, so that's why I'll add moves plus one here. Okay, and then what I will be doing here is, suppose this part is done, so once I come out of the while loop, so that means that if I never return a true, like if I never if I'm never able to reach the destination, then in that case I'll be never returning the number of moves. In that case I'll return minus one, indicating that it is impossible for me to reach the destination part. Okay, so that is what I'll be trying to do. Now let me just go through the code once again. So if it happens that the source and the destination are the same, then I'll return 0 directly. Otherwise, first of all I'll declare a pair and I'll have a visited array as well. And apart from this, what I'll be doing is I'll be having a queue in which I'll be simply pushing all the the starting node, the starting x coordinate, the starting y coordinate, and the 0, and then I'll mark it as visited. After that, if the queue is not empty, then I'll be iterating through the queue, and I'll take out the x coordinate, y coordinate, and the number of moves equal to the target position, and the y is equal to the target position. Target x coordinate and y coordinate are the same. If I get that, so I'll return the number of moves. Otherwise I'll iterate in all the 8 directions, and I'll try to move my knight in all the 8 directions. I'll get the new x and the new y coordinates, and then if the new x is greater equal to the greater equal to 1 and the new x is lesser equal to n, if it is lying in the range and the new y is also lying in the range, and the current cell is not visited, in that case I'll mark it as visited and I'll store it into the queue one by one. Now there's one more thing that I need to implement, that is nothing but the dx and the dy function, right? So what I'll be doing here is, let's quickly write the dx function. So I'll say that, okay, dx of 8 is equal to nothing but 1 comma 1 comma minus 1. Okay, this is a trick with which I remember it. So you can also copy this trick, or you can use any other trick if you want. Okay, so this is how I've stored it. Now I'll say that, okay, the dy I'll store as well for all the 8 directions. So the dy will be nothing but, it will be 2 comma minus, like it will be nothing but 2 comma minus 2. Okay, after that again I'll follow 2 comma minus 2. So this is a pattern that you can see that I'm following. If you want, you can check verify it from here and you can write it. Okay, so 2 comma minus 2 comma 1 comma minus 1 comma 1 comma minus 1 is what I'm going to do here. And now I think I've written it correctly. Let's try and compile it to see if there is any compilation mistake in this code. Okay, so there is one compilation mistake that we are getting. So yeah, so if y is equal to, I should write, so if y is equal to, I think this is a basic mistake. Now let's see if we are getting any other errors in this code or not. Okay, so it gives us the output as 3 on the samples. Let's try and submit this code as well to see if it works on the other cases or not. So you can see that my submission was able to pass all the test cases in the very first go. And talking about the time complexity of this code, so the time complexity of this code, since we are iterating through, like since like see what is the time complexity. So the time complexity of this code will be nothing but order of n square. Why? Because we are iterating through each and every cell. At most we are iterating through each and every cell once only, and the space complexity will be nothing but order of n square, because we are using a visited array to keep a track of the cell that we have visited and to keep a track of the cell that we have not visited. In case if you understood this explanation and the code for this problem, so make sure to hit the like button, comment down understood as well. Thank you for watching this video.